Okay, you're back for more. In this video, we're going to talk about chorus, flanging, and phasing, three different types of time-based effects, all built off of delays. Well, the first two are. And then we're going to go over to Cubase, and you're going to get to hear these types of effects applied to a few different instruments. So we're going to start by talking about chorus. As we've already talked about, chorus is an effect that makes it sound like a lot of instruments sounding together. This is done by taking the original signal and splitting it into at least one, but in sometimes multiple delay lines, and each of those delay lines is modulated with a low-frequency oscillator to change the delay time. And when you change the delay time on a signal, it automatically changes the pitch as the speed goes up and down. And then all of those delayed signals are fed back in and mixed with the original to create the sound of several instruments playing the same part. And it's a nice, warm, rich sound. It adds a lot of depth to a sound. And typically these delay times are very short, somewhere in the neighborhood of 20 to 45 milliseconds. Remember, a millisecond is 1,000th of a second. So we can't really hear those as distinct delays, but when you combine them together with the original signal, it creates this nice detuned effect. Now, as I just mentioned a second ago, when you modulate the delay time, it causes the pitch to go up and down a little bit. Now, choruses can be additionally pitch shifted more to get an even deeper effect, but just modulating the delay itself creates a certain amount of pitch shifting. Now I'm going to play a little audio clip for you here. This is the sound of an electric guitar being played first dry without any chorus, and then with a chorus sound added to it. Okay, I'm sure you could hear the difference there between the dry and the chorused sound. The chorus sound had much more depth to it. It was thicker. It was more interesting to listen to. So that's what a chorus sounds like. Now, what are some of the parameters that you're going to find when you're looking at a chorus effect, whether it's a hardware piece, a guitar pedal, or a plugin that you might be running in your DAW? Well, first of all, you get control over the amount of delay time. Now, as I mentioned, there's not a lot of range there, from about 20 to 45 seconds, but the amount of that delay time will have an effect on how the chorus sounds, so you're able to control that. Then you get a control for depth, or sometimes it's called width, and this will control how much that low-frequency oscillator, or LFO, is going to be changing the delay time as the sound passes through the effect. Then you've got another control which is related to the low frequency oscillator, and that's called speed, or sometimes it's called the rate, and that just controls the speed of the LFO. So how quickly is that LFO causing the delay time to get shorter and longer? And that, of course, will, both of those things, the depth, width, or speed, rate, work together to affect how much the original pitch is going to be altered. Obviously, the more depth you have involved, the wider the amount of pitch shift is going to be. Okay, now flangers are they're an awful lot like a chorus, but we do have a few differences to talk about. First of all, it's a more striking effect. You hear it much more obviously than you do a chorus. It's a sort of a radical effect, so you don't hear it used quite as much. And the delay times on a flanger are really short, between 1 and 10 milliseconds. So that's the biggest difference between a chorus and a flanger, are the delay times. And what this does, when you have real short delays, it creates a series of notches, that's a notch, and a peak, to create a special kind of a filter called a comb filter. And we call it that because these notches look like the teeth of a comb. And in a flanger, these notches are created by delays, and the notches are not harmonically, or they are harmonically related to each other. So the first notch might be at 100 hertz, the next notch would be at 400, the next one at 800, 1600, and so on. So in a flanger, the notches in the comb filter are harmonically related to each other. So when we change the delay time, we get this really intense sweeping effect. Sounds kind of like a jet plane sound. And we can also feed that signal back into the delay, into the processor, to intensify that effect. The higher you turn up the feedback amount, you heard that on the delay demo, pretty soon it can even start to feed back and ring on itself. Flangers can do the same thing. So if you crank that up too high, you can actually cause the thing to go into overdrive, and because it's feeding back on itself so much, it just creates an endless loop. Now, there's a lot of stories, myths about how flangers were invented, but the most widely accepted one is there was an engineer that was working at Abbey Road with the Beatles and put his hand, the engineer's name was Ken, and so John Lennon named it Ken's flanger. They had two tape recorders that were synchronized to each other, and when Ken put his hand on one of the tape reels, or the flange of the tape reel, it slowed that tape down a little bit, and that created a very short delay, which created the flanging, swooshing effect. So that's a little bit of history about how flangers supposedly got their name, by putting your hand on the flange of a tape reel. So here's sort of a graphical representation of a comb filter with the notches and the peaks, and this is the sound of a drum set being played through a flanger. Okay, so that's flangers. And the parameters we have on there are depth. This is how much flanging is applied. This will create deeper notches in your filter. And as I mentioned, the notches are harmonically related. The delay sets the delay time. It's very short delay, but you still get a control over it. Then we have, again, a depth and width control. This controls how much the low-frequency oscillator is going to change the delay time. Is it going to be just a narrow amount of change or really a lot of change, which would be wide? And then we can control the speed of the LFO, which is how quickly the depth is going to be modulated. And finally, on a flanger, we'll have the feedback control, which lets us feed the signal back into the effect processor. One more, we've got phasers to talk about. Now, phasers are a little bit different. They sound kind of like a flanger, but they're not as intense, and they don't actually use delays. They use a chain of what are called all-pass filters, and these all-pass filters work on the entire frequency range, and they modify the phase of the input signal, and then that phase-shifted signal is mixed back into the original, and the amount of that phase shift is controlled or modulated with an LFO, just like our others work with LFOs that are controlling delay times, but now the LFO is working on the phase shift. And the number of these all-pass filters we have will determine how complex the phasing effect is. For every all-pass filter, well, you need two basically, one to create a peak and one to create a notch. So in order for a phaser to have any sound at all, you need to have at least two of these all-pass filters, and as you add more, sometimes up to 30 of them, it will intensify the effect and make it more dramatic. Now this creates a comb filter, just like a phaser does, and we modulate the phase with the LFO to create the sweeping effect. But the difference between a phaser and a flanger is that the notches in a phaser are not necessarily harmonically related to each other. The amount of phase shift is going to control where the notches in the comb filter are. So we don't have that harmonic relationship in our notch filter or comb filter the same way we did with a flanger. What are some of the controls that you're going to get? Not quite as many. You get a depth control. That's control the amount of phase shift that's generated by the LFO. You get to control the speed, or sometimes it's called rate, which is the rate of the LFO. And then the feedback sends the signal back into the effect, and that creates higher peaks and deeper notches, and that creates a more resonant stronger effect. So two things you can do to intensify this effect. One is to turn up the feedback, and the other is to add more all-pass filters. Now we're going to go over to Cubase, and we're going to apply these effects to some various instruments so you can hear what they sound like. Okay, here we are back in Cubase. And I've created two tracks here. One is a recording of a real electric guitar. And up here I've got Hallian Sonic again. And I've loaded up a string sound into that. And I will be using that to show you, I'll be using both of these actually, to show you the difference in sound between chorusing, flanging, and phasing. So let's listen to this guitar track, just clean and dry. Nothing on it. This is just the sound that came out of the amp. It's a little vibrato going on. That's probably the guitarist playing with his whammy bar to get those effects. So just like any of the other examples here, we're going to click on our channel to bring up the channel settings. And I'm going to use an insert because I'm going to be applying this chorus just to this guitar. If I wanted to apply the same chorus to both this guitar track and the string track, then I would do it as a send and not an insert. But since I'm going to use it just on the guitar, we'll use an insert. So all of those kinds of effects, phasing, flanging, and choruses are found in Cubase under the Modulation tab. So let's open up a chorus. Okay. And here's our rate. So this is the rate of our delay. Or the rate of the LFO, sorry. So that's how fast the delays are being modulated. This is the delay time. So you can see by changing that delay time, it changes the quality or the sound of the chorus. And that's the width, how wide, how much change in the delay time. And as soon as I do that, you can start hearing that detuning going on. That's created by changing the delay times will change your pitch. Here's our dry-wet mix. So that's dry. And then I can dial in as much of that chorusing effect as I want. And it can go from very subtle to pretty extreme, especially. So that would be an example of extreme chorusing. Now normally you don't have nearly that much. Now we also have some presets, so if I want to go in here and pick from a preset that they've already created at Steinberg, they give you a bunch of those. So you can get in there and find something you like, and then maybe tweak it a little bit to get it to sound more like what you want. So there's a chorus. Now we'll go in and choose a flanger. Get rid of our changes there. So you can already hear that sweeping sound going on. So again, we get our delay time. Now notice how much shorter the delay time is now. It's at 2 milliseconds. When we were in the chorus there, it was quite a bit longer. I think we were sitting around 25 or 30. So we can go up to 10 and down to 0.1, which is really, really low. And here's our rate. That's how quickly our LFO is modulating our delay time. A little EQ. You're going to get some parameters on some effects processors that are different than others, but you're always going to find the basic ones that we were talking about, which is your rate, your depth, the amount of delay, your feedback amount. That's how much signal's getting fed back in, and that creates our steeper notch filters. And notice this is synced to the tempo, so it's showing me my rate in musical notes. Now it's showing me my rate in hertz. So you can look at it either way. Spatial gives me more of a stereo spread. And here's our dry wet mix. And you actually hear most effect when you've got those mixed pretty evenly. So, because the way these work, you have to have the original signal and then the affected signal fairly both present in the mix in order to hear what the effect is going to do. Last one is a phaser. Let's do a phaser. Okay. And we'll just spin through a couple of the presets here. Now you can hear it's a similar kind of effect. So what does fast moderate sound like? So our rate's pretty quick here. Width is our depth. Remember these different words sometime. So let's slow down the speed. And increase the feedback so we get deeper notches in that comb filter. So you can hear that it's not quite as intense. Let's turn up the mix a little bit. It's not as intense as a flanger, and it's not as thick as a chorus. It's a more subtle effect, but cool nonetheless. So that's how those things sound on a guitar. We'll turn that off, and we'll close down this channel editor. And let's mute our guitar track and go to our string track and unmute that. All right, so I'm just going to throw those same effects on this string track so you can hear what they do. So once again, we click E, we'll go over to an insert, and this time I'm going to do it a little bit different. I'm going to load up a chorus, and let's load a preset. How about wide backing vocals? Not hearing too much there. Let's choose something that's a little more predominant. There we go. That's a little bit thick on the mix. And we'll slow it down a little bit. Okay, and I can bypass that. I'll just do that. And then I'm going to go down here and we'll open up a flanger. And maybe let's load a preset. How about middle medium? And I'm going to slow that one down a little bit too. I like slow sweeps. Okay, we can bypass that. Let's line these up down here. And then finally, we will put a phaser. So that's, again, under modulation. Call up a phaser. Oh, yeah. I actually like that one. Okay, so now I've got all three of them lined up in a row. There's our chorus. There's our flanger. There's our phaser. Let's turn on each one at a time so you can hear what's going on. Make that a little bit more intense. There we go. Now you can really hear what that chorus is doing. I'll turn that off. Turn on our flanger. Turn that one off and turn on our phase shifter. And you can really hear that flange and that phase are very close. They really do the same kind of thing, but in a slightly different way. And just for fun, let's turn all three of them on. Really mangle that sound. There's nothing that says you can't use more than one modulation-based effect on a sound at a time. You can stack them up however you want. You've got 8 inserts over here, and you've got 8 sends, so you can really load up with a lot of effects. All right, there you go. Demonstration of chorusing, flanging, and phasing. Catch you next time.